morning, everybody. So, as we all know about Lee Chatterjee principle, which states that a change in any one of the factors, that may be concentration, temperature, pressure, addition of inert gas, volume, that determine the equilibrium conditions of a system, will cause the system to change in such a manner so as to reduce or counter effect the effect of the change. So for this, out of those many factors which affect equilibrium, chemical equilibrium, we are going to take one of the factor today for the activity, and that is the effect of concentration on chemical equilibrium. So to study the effect of concentration, change in concentration on chemical equilibrium, we are going to study the reaction between ferric chloride and potassium thiocyanate. So for this, we will take 0.1 molar ferric chloride solution and 0.1 molar potassium thiocyanate solution. As we all see, color of ferric chloride is pale yellow and potassium thiocyanate is colorless in nature. Now we add 0.1 molar ferric chloride solution to the beaker. And to this we will add 0.1 molar potassium thiocyanate solution slowly and slowly. And we will see the change in color. As we keep on adding, we see that blood red color is produced and there is no change in the intensity of color. At this stage, color remains constant. No changes there. It means this reaction has attained the equilibrium. So, as we see, the reaction which happens in this is ferric ions from ferric chloride reacts with thiocyanate ions from potassium thiocyanate to form complex ferric thiocyanate complex, which is deep red in color. So formation of deep red color indicates the formation of complex ferric thiocyanate. Now we will dilute this solution. Now we will transfer little amount of this solution to another beaker and dilute this solution by adding water. Solution is diluted. Now we will take 5 milliliter of this diluted solution to 4 test tubes. As we have taken this solution, so we take 4 test tubes in which we take equal volumes of this solution. Okay? Of solution of complex ferric thiocyanate, this solution. So in the first test tube now, we are going to add 5 milliliter of water. So we'll add 5 milliliter of water to it, and we will keep this solution as our reference solution. So this is our reference solution. Now in the second test tube, we will add 5 milliliter of ferric chloride solution and see what happens to this solution. You all will see the color change. You will see, and if we compare these two solutions, reference solution with the second test tube, we will see there is a change in the color, and color is what we observe when we mix ferric chloride solution with potassium thiocyanate solution. It means product formation takes place. Deep blood red color indicates the formation of complex between ferric ions and potassium thiocyanate ions. So it means equilibrium has shifted in the forward direction, that is towards product side, means more and more product formation takes place. Now let's add 5 milliliter of potassium thiocyanate solution to the third test tube, and let's see what happens in this also. thiocyanate ions. So it means equilibrium again shifts in the forward direction. So we can conclude one thing from these two additions, that whenever we are adding or we are increasing the concentration of reactants, that is ferric ions and thiocyanate ions, equilibrium is shifting in the forward direction, means towards the product side, so as to counter effect the change. So now let's see what will happen if we decrease the concentration of our reactants. Okay, for this we will take our fourth test tube and add oxalic acid solution to it. So when we add oxalic acid solution to it, we will see the color become diminished. So this indicates equilibrium is not shifting in the forward direction, that is towards product side, it is shifting in the backward direction towards the reactant side. The solution which we add is the solution of oxalic acid. It means there is some role of oxalic acid. We are not, oxalic acid is not there in our reactants, neither in our reactants nor, now we are adding it. So what oxalic acid is doing, it is forming complex with ferric ions, thereby reducing the concentration of ferric ions in the solution. So since concentration of reactant is decreasing, which is ferric ions, so equilibrium is shifting towards the backward direction, that is towards the reactant side. So we can conclude our observations in this manner. So if 5 ml of water is our reference color, so when we add ferric chloride solution, color deepens or color increases, means equilibrium is shifting towards right side. When we add 5 ml of potassium thiocyanate solution, color deepens again, which means if a concentration of product is increasing and equilibrium is again shifting towards the right side. And when we add 5 ml of oxalic acid solution, color becomes lighter. It means concentration of our product is decreasing and equilibrium is shifting towards the left hand side. So we can conclude that at equilibrium, an increase in the concentration of any of the reactant will shift the equilibrium of reaction in the forward direction, while decrease in concentration of any of the reactant will shift the equilibrium in the backward direction.